Okay, and hello to the next video, and welcome to the next video where we're looking at another type of graph called a quartic graph, something which you might not have come across before at GCSE. It's an extension of the cubic graphs, and we're going to look at the various facets of this type of graph and how to sketch it. So, a quartic graph differs from a cubic graph in which the highest power in the equation is not 3 but 4, and every other power decreases by 1. The point where the curve crosses or touches the x-axis again should be labelled. The x-intercepts can be found from the factorised form, and the y-intercept can be found by letting x equal 0 or finding e by expanding the numbers in the brackets. A quartic function with one repeated root will have one turning point. If you got a value of a, if the coefficient of a is positive, then you will have a minimum point. If the coefficient of a is negative, you're going to have a maximum point. So this is a positive quartic, negative quartic. Okay. Now it's really important to note that although this might look quite similar to a quadratic, if you were to zoom in on this section here and here, that it's actually a lot more squished towards the x-axis compared to quadratic. Quadratic will be a lot more steeper. The reason for this is as you get between 1 and -1, when you do numbers between 0 and 1 and 0 and -1, fractional numbers, if you do them to powers of 4, you're going to get very low y values, okay, which explains this behaviour here. Again, if you've got a repeated real root from a cubic, that gives a point of inflection. Okay, so sketch the graph of the function x plus 2 to the power of 4. So again, let's just pencil and ruler. Now x plus 2 to the power of 4, so that means it's got x plus 2 times x plus 2 times x plus 2 times x plus 2. Now you don't need to write this, I'm just doing it for the sake of this example. So obviously it's clearly going to cut the x-axis at -2. Okay, clearly going to cut there at -2. What about where it cuts the y-axis? Well, we just multiply, expand the numbers of 2, so the y-intercept is going to be times 2, 4, 8. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. Okay, so it's going to cut at -16, at 16. Okay, and obviously if I was to expand the x terms together, I'm going to get a positive quartic, which means I'm going to get something that looks like this. Okay, so all I need to do is literally just use that and use an intercept of -2 instead. Okay, and that's it. Not too difficult. I'm sure you will agree on that particular example. Okay, so with this sort of stuff, you can see the skill set is very, very similar to the cubics and quadratics. And knowing that, let's go down to example 2. Got to sketch the graph of this. Now we can clearly see this graph is going to be very different. So the x-intercepts will be 1, 2, 3 and 4. Okay, so 1, 2, 3 and 4, and let's go extend the x-axis just a little bit more. And the y-intercept, if I multiply the numbers together, so -1 times -2 is +2, -6 plus 24. Okay, now if you think about this, it's going to go Okay, so I'm just going to use my rubber here. It wasn't the best sketch at that point. Okay, now you might be thinking to yourself, why does it exhibit this sort of nature? Well, quartic x to the power of 4, another way of seeing that is it's got a squared, it's like a quadratic multiplied by itself. So when you've got, essentially what you've got is two different quadratics. You've got x minus 1, x minus 2. So that forms that nature, the quadratic nature here. But because you've got another quadratic multiplying by that as well, you've got then this quadratic nature here. So that explains the overall behaviour and the overall design of this graph. Okay, right. Those are the first two. I'm just going to go to the next one here. This is quite an interesting one because we've got repeated roots, as you can see, x minus 1 times x minus 2 squared. Okay, so again I'm going to draw my graph, and I'm just going to write out the equations as I see them. Okay, right, the first intercept will be obviously 1, the next one will be 2, and the y-intercept will be minus 1 times minus 1 is plus 1, 4, okay, so what we've got here is two repeated roots. We've got one at 1, got one at 2, and if you remember from cubics, when you've got a repeated root you have a point of inflection, and a point of inflection will sort of look like this. Okay, so that's how we deal with point inflections with quartics. And the final one, sketch the graph y equals x minus 1 cubed times by x plus 2. It's going to be a bit tricky here, but we can still use our skills from the previous video to help us. So it's going to look something like this. Therefore it intersects at 1 and minus 2, and the y-intercept is going to be, well, minus 1 times minus 1 is plus 1, minus 1, minus 2. Okay, so we intersect at minus 2. Okay, so with regards to this type of graph, we've got to be a bit careful here. Now, it's going to cut, it's obviously a positive quartic, it's going to cut at minus 2, but we've got to remember at 1, it's got a point of inflection. Okay, now the point of inflection is going to be slightly different here. Okay, so it's going to start from minus 2, going to cut through minus 2 on the y-intercept, going to exhibit this sort of nature here. Okay, the reason for that, again, if you were to analyse the type of graph that we've got here, we've got a cubic type of graph. We've got x minus 1 cubed, and we've got a linear type of graph. Okay, so you've got a cubic nature and you've got sort of linear nature coming down from here. Okay, so we've got to be very careful with this, but this is, I would say this is the harder end of the scale. Likelihood of it coming up is quite low, but still quartic graphs, again, it's just an extension of cubic graphs, and as long as you know the main points and you know the types of quartics, positive and negative, x and y intercepts, you'll be fine. So here are the practice questions outlined below, and good luck. End of the video.